Alright, so continuing with chapter 14, we're going to cover two sections with this video, section 2 and section 3. So section 2 is on work and machines. So what exactly is a machine? It's a device that changes a force. And that force can be changed in 3 different ways. And the ways that it changes the force is going to make work easier for us to do. Now it can change the size of the force needed. It can change the direction of the force, or it can change the distance that the force is acting over. Now we can increase the force by using a large force for a short distance, or we can use a small force over a long distance and still have that same amount of work being done. We can do the same with distance. We can have an increased distance with a small force, or we can have a small distance with a large force. You're still getting the same amount of work being done. Now, from section 1, we looked at work and what the formula was, W equals FD. We're still going to be using that for this section. We have work input and work output now. So we're talking about a before and we're talking about an after. So because of friction, and remember friction is an opposing force of motion, the work that's done by the machine, your output, is always going to be less than the work done on the machine, what goes into it. So our input, we have an input force and an input distance. That's what's going into the machine. And to solve and figure out what work input is, again, it's the same formula. We have work is equal to your force multiplied by the distance. It's just all of your information from before it goes into the machine. We also have output. Output is what comes out of the machine. And again, remember, output is always less than input. So we have a force, we have a distance. We're still using that same formula, W equals FD, but this time it's for your output, what you're getting out of the system, your end results. Now we are going to go ahead and continue. We're going to talk about mechanical advantage and what we call efficiency. This is section 3. So mechanical advantage is the number of times that a machine increases the input force. So how much easier is it making the work? So we have a couple of different types of mechanical advantage. We have the actual mechanical advantage, or AMA, as we're going to call it for short. And it's equal to the ratio, now remember I said ratio is a division problem, of the output force to the input force. So we're only looking at force here for AMA. So output force divided by the input force. We also have ideal mechanical advantage. So this would be in a perfect situation where we don't have friction slowing us down. And this is IMA. And this is, like I said, when we have no friction, but your IMA is actually going to be your greater number. So it's your actual distance. So input distance divided by output distance. So here's an example. A woman drives her car up onto some wheel ramps and she's going to perform some repairs. If she drives a distance of 1.8 meters along the ramp and she wants to raise the car 0.3 meters, we want to know what is the IMA, what's the ideal mechanical advantage she has from those ramps. Don't look at me. So IMA is equal to your input distance, so what she's actually doing, divided by the output distance. So in this case, 1.8 meters, that's the distance she's driving. That's your input distance. And then the 0.3 meters is what the ramp is doing. So it's raising her car 0.3 meters. So 1.8 divided by 0.3, your IMA should be 6. And because we have meters divided by meters, IMA and AMA do not have units. So practice problem. A student is working in a grocery store and pushes several grocery carts together along a ramp. The ramp is 3 meters long and it rises 0.5 meters. So what is the IMA of the ramp? Well, again, your input, what you're actually doing, is 3 meters. What the ramp is doing for you is rising 0.5. So what is 3 divided by 0.5? And that would be your answer for the practice problem. So now let's move on. Let's talk about efficiency. Efficiency is a percentage of the work input that becomes work output. So remember, we said that output is always less than the input. Now, in an ideal situation, again, there's no friction, there's nothing slowing it down, efficiency would be 100%. But because we live in a world where we have friction and have other forces coming into play here, efficiency will always be less than 100%. So how we calculate efficiency? It's your work output divided by the work input, and then you multiply that by 100, and you will get a percentage. And that's it for today.